in this question, you are supposed to find the two values of y such that this equation is satisfied. That is, the absolute value of y squared plus 1 is equal to the absolute value of y plus 13. So here you're going to have to discuss whether the values in the absolute value are positive or negative, right? Or equal to 0. So in this case, you're going to write, for the first case, you have y squared plus 1 is greater or equal to 0. So 0 or positive. And that this one, so y plus 13, is also positive. So y plus 13 is also positive or equal to 0. So these two need to meet, so intersect, as well as this. So these two conditions need to be met, and as well, y has to satisfy this equation. So that's case 1. And also another case you have is y squared plus 1 is smaller or equal to 0. And here y plus 13, here this is going to be greater or equal to 0. That's another case that you can consider, right? And of course, it's all intersection. And you also have y squared plus 1 is greater or equal to 0. And also that y plus 13 is smaller or equal to 0. Okay? And also you have y plus 1 is, both are smaller or equal to 0. So y squared plus 1, smaller or equal to 0. And y plus 13, also smaller or equal to 0. Okay, so the first thing you want to do here is consider which cases are just not possible at all. Well, if you take a look at this, y squared is always going to be positive, and then add another positive number, there's no way you're going to get something smaller than 0. So this case, you don't have to consider. And it's the same with this one here, right? Because y squared plus 1 always greater or equal to 0. In fact, this is always going to be greater than 0 because you have plus 1. So in this case, you don't have to consider these two. So I'm going to erase them. So now you just consider these two cases where the y squared plus 1 is always greater or equal to 0. These two cases are the ones we're going to look at. So here in this case, if you take this part and you write and you move 13 on the other side, well then y is going to be therefore greater or equal to negative 13. So this condition has to be met. We're just going to write this in this form. So now that you've considered the cases, you can now take out the absolute values. So then you write y squared plus 1 is equal to y squared plus 13. And now you want to move everything to the left side. So that's y squared minus y is, y squared minus y minus 12 is equal to 0. You can use the formula, or you can use factoring as well. So if you factor, you get y minus 4, and then times y plus 3 is equal to 0. And now here you can see that y is equal to 4. That's one solution. And also y is equal to negative 3. So now we have to consider, does this, so we have two solutions, do either one of these have an intersection with y greater or equal to 13, negative 13? Well, in this case, yes, because here y is equal to 4 and y is equal to negative 3. That's all going to be greater or equal to 13. So that works. And we're going to now, so now that we have this, we're going to write this on the side. So, oh, sorry. There we go. So y is equal to 4, so that's one of them. And also that y is equal to negative 3. Now, I did say that there were two solutions, and since you already got two, you can stop here. But for educational purposes, we're going to consider this case as well. So here, we're going to write y is smaller or equal to negative 13. So here, these conditions need to be met, so that's the intersection. And here, now that you considered cases, you can write y squared plus 1 is equal to, in this case, if y is going to be negative, so smaller or equal to negative 13, well then it's actually going to be equal to negative y plus 13. And then now you want to write y squared plus 1 is equal to negative y minus 13. Now move everything to the left side. So in this case, you get y squared and then plus y is equal to 14. It's not equal to, but plus 14 is equal to 0. Okay, so, well, you can go ahead and solve this with the formula, but let's just take the part where in the formula it's b squared minus 4ac. Well, in this case, what is b squared minus 4ac? Well, in this case, if you take b squared minus 4ac, well, b is 1, so then that's 1 squared minus 4a, and then c, which is 14. Now, just looking at this, you can tell that there is no solution because 1 minus 56 is going to be negative, and the square root of a negative number is not a real number. So in this case, there is no solution. So your only solutions here are y equals to 4 and y equals to negative 3. And therefore, you have the two values of y that satisfies this equation. In this question, we're going to draw the graph for this equation. X minus 2 is equal to the absolute value of y minus 3. So first, we're going to have to discuss for y minus 3, since that is the part inside the absolute value. So we're going to write the first case here as y minus 3 is greater or equal to 0. So that's positive. And then here, at the same time, we have to make sure that x minus 2 is equal to y minus 3. So that's case 1. And case 2 here is y minus 3 is smaller or equal to 0. And here, x minus 2 equals to, well, since here, in this case, y will always be smaller than, in this case, y minus 3 is smaller than 0, so you have to write negative y minus 3. And like that. Okay, so here, for the first case, we're going to actually isolate y to get the equation of the line. Well, then, if you isolate if you isolate y by adding 3, well, then you get y is equal to x, and then plus 1. Now, for the second case, if you were to isolate y, well, then here, x minus 2, this is equal to negative y plus 3. And then you move 3 into the other side. Well, then that's x minus 5 is equal to negative y. Well, then y is equal to negative x plus 5. So now you have two line equations. Now you're going to want to draw them out on a coordinate plane. So let me draw a coordinate plane right over here. So like this. How about like this? Like this. Okay, so you can draw little points here just so that your graph could be a little bit more accurate. I'm also going to do it because I can't draw very accurately. So here, for the first line equation, y equals to x plus 1, well then you have a slope of 1 and y-intercept of 1. So here in this case, this is y-intercept of 1. You draw the line something like this, just roughly. You don't have to get it exactly right. So you have something like this. However, this will only hold, I should probably write the condition here. So this will only hold when y is greater or equal to 3. And this part here is y is smaller or equal to 3. So in this case, if you draw the y equals to 3 line, well then you get this line. You get this line. So here, only this part, including the part with y equals to 3, only this part and so on is going to remain because that's the only part with y greater or equal to 3. So then you don't want anything below here. Oh, sorry. And I need to remove this line too. I need to kind of redraw it right now. So in this case, just for reference, okay, so somewhere like here, right? I hope I don't remember clearly, but just roughly shouldn't have that big of an impact. So that's y equals to 3. Sorry, that's y greater or equal to 3. So now we're looking at this second equation right over here. Well, this is a negative slope, and this is a y-intercept of 5. So this means that you're looking at a line like this. Like that. There we go. How about this? Like that. So that's y equals to negative x plus 5 with a y-intercept of 5. And here, in this case, you want to get everything below this blue line, which is y equals to 3. So in this case, you're only going to keep this part of the line. So in this case, you want to remove this top part and redraw the line because I don't want to. You don't want that top part as well. So you're only getting this part remaining. And now, once you remove this y equals to 3 line, you can get a proper graph of what your graph is supposed to look like. And this is indeed the equation. This is now the equation. We have drawn it for x minus 2 is equal to absolute value of y minus 3.